This lesson covers what's called complex fractions. Complex fractions is when you have a fraction with a numerator that consists of fractions and a denominator that also consists of fractions. These can be simplified in a couple of different ways. It does not matter to me which way you choose to simplify these. I would suggest pick a way that you like and then be consistent. So on this first problem, I'm going to show you both methods. And then after that, I'll just pick a different method for each problem so that you can see sort of how this looks. Method 1, I'll do in pink. Method 1 is simplify the numerator, simplify the denominator, then divide. So my numerator here is 3/4 minus 1/8. My denominator is 2 plus 1/12. So when I simplify the numerator, I see that my common denominator is 8. So I have to multiply the first fraction by 2 over 2. I get 6/8 minus 1/8. On my second fraction, my common denominator is 12. So I have to multiply this by 12 over 12. And I get 24/12 plus 1/12. So from here, 6/8 minus 1/8, that's 5/8, divided by 25/12. Copy dot flap. Four goes into this twice, here 3 times, and we end up with 3/10. The second method is that you actually find the least common multiple of all of the denominators, and then you multiply every single fraction by that value. So if I've got 4, 8, and 12, not 112, just 12. So, least common denominator. So there's 2 2's. I'm left with a 2 and a 3. So now I will multiply everything by 24. So when I multiply this by 24, multiply that by 24, what happens is that denominator cancels, that one cancels, that one cancels, leaving me with 18 minus 3 over, 48 plus 2. Either way, you get the same answer, so it really is your preference. This kind of problem is a little tricky because you've got all these negative exponents, and a lot of you are going to want to flip this fraction. You will be incorrect in doing so. This is 1 over r cubed plus 1 over s cubed over 1 over r plus 1 over s. So here's one where I will use method 1. Simplify the numerator and denominator separately, then divide. So 1 over r cubed plus 1 over s cubed. My least common denominator would be r cubed, s cubed. I would have to multiply this by s cubed over s cubed, and this by r cubed over r cubed. So my numerator is s cubed plus r cubed. Now when I do the denominator, I have rs is my common denominator, so that's s plus r. Now what I need to recognize is that this is a sum of cubes, and I have a formula for that. It is s plus r times s squared minus rs plus r squared. And I'm multiplying this by rs over s plus r. Now what happens, I'm not going to rewrite this again. Anytime I have the same factor in the numerator and denominator, they cancel. This cancels, that cancels and becomes a 2, that one cancels and becomes a 2. So I am now left with s squared minus rs plus r squared over r squared s squared. A lot of you will want to cancel. You may not do that. You must leave it just like this. On the next problem, I will use method 2. So this is the one where I'll find the common denominator of everything and multiply. Well, in this case, the common denominator is x squared. So I'll multiply this by x squared, this one times x squared, this one times x squared, that one times x squared, and that one times x squared. Here, this cancels, that cancels completely, and that cancels. So I'm left with x squared plus 3x plus 2 over x squared plus 2x. My numerator can be factored. My denominator, I can factor out an x. And I see I have a common factor, and I'm left with x plus 1 over x. You may not cancel these. This is your final answer. And I'll circle this final answer too. For this next one, I'm going to kind of combine method 1 and method 2. So I'm going to start by focusing just on the numerator. And what I want to do is, I want to multiply everything in the fraction by the common denominator u. So I'm going to multiply the numerator by u, and then I'm going to multiply each term in the denominator also by u. And what I'm left with is u, that's this one, plus u over u plus 1. Now I have a common denominator of u plus 1. So I can multiply this u times u plus 1 over u plus 1. And that gives me not that. So that means I've got, and I'm going to come up a little bit, u squared plus u over u plus 1. So that would be u squared plus 2u over u plus 1. And then I can simplify that a little bit further, that it's coming down here. I'm sorry, my work's all over the place. U times u plus 2 over u plus 1. Now we can't forget about this denominator, right? So we would divide by this, or we would copy dot flop. So there's my dot, my flop is u plus 1 over 1. These cancel, and you're left with u times u plus 2. This last one is another one where I would probably rather use method 1 rather than multiplying everything by u plus v times u minus v, because that would be the common denominator of everything. So when I deal with the numerator, I can multiply this by u plus v over u plus v, and this one by u minus v over u minus v, and that gives me u plus v squared minus u minus v squared over u squared minus v squared, right? Because it's just a difference of squares. I will need to expand all of this and refactor it, so I get and when I combine like terms, u squared minus u squared, 2uv minus negative, that's plus 2uv, so that's 4uv, and then v squared minus v squared. Now I need to deal with the denominator. I've got u plus v over u minus v plus u minus v over u plus v. Have to do the same thing. This gives me u squared plus 2uv plus v squared plus u squared minus 2uv plus v squared. So these cancel. You have 2u squared plus 2v squared. And we can factor out a 2 if we need to, although I don't think it will make any difference. Nope, it won't. So we copy dot flop. These cancel. This cancels. And we are left with, I'm going to write it in blue, 2uv over u squared plus v squared. There's that answer.